Understand the thermodynamics of the dissolution process. Dissolving an ionic solid in water can be modeled as three thermodynamic steps: solute separation, breaking the electrostatic attractions holding the ions in the crystal lattice. This step is always endothermic, delta H greater than 0, because it requires energy to overcome the ionic bonds. Solvent separation, breaking the hydrogen bonds between water molecules to make room for the solute ions. This is also endothermic, delta H greater than 0. Solute-solvent attraction, hydration forming new ion-dipole interactions between the separated ions and the polar water molecules. This step is always exothermic, delta H less than 0, because forming attractions stabilizes the system and releases energy. Analyze the overall sign of delta H degree solution. The net enthalpy change, delta H degree solution, is the sum of these steps. Delta H degree solution equals delta H solute separation plus delta H solvent separation plus delta H hydration. If delta H degree solution is positive, endothermic, the energy required to break the existing attractions, solute-solute and solvent-solvent, must be greater than the energy released when forming the new ion-dipole attractions. Relate the positive delta H degrees to calcium fluoride structure. Calcium fluoride, CaF₂, contains Ca to the power 2 plus cations with a +2 charge and F to the power negative anions with a -1 charge. According to Coulomb's law, the high charge density of Ca to the power 2 plus and the small ionic radius of F to the power negative produce exceptionally strong ion-ion electrostatic attractions within the crystal lattice. Select the correct explanation. Because these ion-ion interactions in the crystal lattice are so strong, they require a very large input of energy to break, delta H solute separation Gg0. This massive endothermic step dominates the hydration energy, resulting in a positive net enthalpy change. This makes option C the correct answer. The correct answer is option C. Ca2 plus ions have very strong ion-ion interactions with F- ions in the crystal lattice.